As we continue here, we want to talk about, as we continue talking about parallelograms, let's talk about the special parallelograms and their relationships. And in doing that, let's think of what are the properties of our parallelograms. And as we look at this parallelogram, we want to remember that, let's see here, we do have two sets of parallel opposite sides. We do have congruent opposite angles, and those are, some of the key properties to a parallelogram. And we also know that our diagonals will bisect each other, which means that they cut each other at half at the midpoint here. And that, let's see here, what other properties can we think of that angle M, if I get rid of that junk, right? I know that angle M plus angle L is going to equal some magic degree of 180 degrees. So consecutive angles within a parallelogram are equal to 180 degrees. So those are just some of the properties that we want to go back and think about when it comes to parallelograms, and how do they now apply for these special parallelograms. And all of these properties will still remain constant, but they are going to have, these special parallelograms are going to have a additional relationship. So the properties of rectangles, when is a parallelogram a rectangle? Well, a rectangle, we find out, is a parallelogram with 90-degree opposite angles. And as such, a rectangle, the rectangle angle theorem, we have a parallelogram is going to be a rectangle if one of its angles is a right angle. Because if one of these angles is a right angle, we know that that angle Q as a parallelogram plus angle T is going to be equal to 180 degrees, or the measurement of those two angles. So if angle Q is 90 degrees, then we know that angle T should also be 90 degrees. So if one angle is a 90-degree angle, then it turns out that all of the angles are going to be a 90-degree angle, because we know that the opposite angles of a parallelogram are congruent. So it turns out that, again, if we have one 90-degree angle, we end up having all four angles are 90-degree angles. And then the rectangle diagonal theorem. Now, a parallelogram is a rectangle if and only if its diagonals are congruent. So we also find out here that my diagonals in a rectangle are going to be congruent. So this segment is congruent to that segment. And so the diagonals of is a parallelogram is a rectangle if and only if its diagonals are congruent. So we know that segment ST is going to be congruent to segment QR in order for it to be one of those characteristics of a rectangle. So to find the missing measures here, we got to remember, let's see, rectangles have the same properties as parallelograms. So same properties of parallelograms. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. So if we do, let's see, I know that opposite sides are congruent. So this side is congruent to this side. This side is congruent to this side. Okay. What else do we need to know? Opposite angles are congruent. Okay. And we know then that opposite angles are congruent. And we know that that rectangle is 90 degrees. and consecutive angles are supplementary. Okay? And then diagonals bisect each other. So I know that that is equal to that. That is equal to that. And since they bisect each other, actually I know that those two, all of my diagonals, right? So all of my diagonals, since my diagonals equal each other and they bisect each other in half, then those segments are equal to each other, and I know that T is a midpoint. So let's see, what do we have? We have QR is 10. SR is 24. SQ, I don't know, I haven't calculated the length of this diagonal right here, but I do know that if this is 90 degrees, I can use the Pythagorean theorem. So I know that a squared plus b squared equals c squared, and in this case, a squared could be ps squared, right, plus pq squared is going to equal c squared, and do some substitution. And let's see here, we got 100 plus, all right, so we have, what is this, 24 squared is 576 is equal to c squared, or SQ, right? So that is 676 is equal to c squared. Do the square root of both sides, and it turns out that c is going to be equal to 26. So we know that SQ is going to be equal to 26. If SQ is equal to 26, we know that PR is congruent to SQ. So PR is going to be equal to 26. And then QT, QT is going to be 1/2, right? Because it's bisecting. So QT is 1/2 of the entire diagonal, which is going to be 13. And there we are, we're using properties of parallelograms and those special characteristics of a rectangle to fill in the blank and find out what some of our missing measurements are. Now, as we continue working with these special parallelograms, we have the properties of a rhombus. So when does a parallelogram become a rhombus, or when is a rhombus? Well, we do still have the same properties, but a rhombus will add that we have 4 congruent sides. So that is the additional property for a rhombus, is that we have, I said 4 additional sides. I meant 4 congruent sides. So a rhombus angle bisector theorem, or the rhombus angle bisector theorem, is we have a parallelogram as a rhombus if and only if each of its diagonals bisects 2 of its angles. So, its diagonals bisects 2 of its angles. So if we draw our diagonals in here, we would have segment EG and segment FH, and they would in turn bisect. This angle would be congruent to this angle, and then this angle would be congruent to that angle. So it would bisect our opposite angles. And then a parallelogram is a rhombus if and only if, again, if and only if its diagonals are if and only if the diagonals are perpendicular. Okay, so let's see here. If and only if its diagonals are perpendicular. So here we know then that we end up with another characteristic of a rhombus is that our diagonals will be perpendicular. They will intersect at perpendicular 90 degrees. And then that will end up giving us, by side, 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 all 4 angles formed by the diagonals will be congruent. Okay, so let's see here. We know that the diagonals bisect each other as a parallelogram. So we know then that this segment is equal to this segment is equal to this segment, and then there we have a side congruency, because this side, each triangle has side congruency. So there you go, we created 4 congruent triangles. Now these rhombi will continue on, and we know that they are going to be, what are these properties? What are these characteristics? Parallelogram. So rhombi are parallelograms. They have 4 congruent sides. They have diagonals that are angle bisectors. And then also they have perpendicular diagonals. Diagonals. They have perpendicular diagonals. So here, if we try to use some of these characteristics to solve a problem, let's see, what do we know? We know that our sides are congruent. We know that our diagonals bisect each other, making V a midpoint. Now let's see here. So let's just look at, they've given us RT, so RT is equal to 22 in that angle segment theorem. So I know that RT is equal to RV angle segment theorem. That doesn't make any sense. How about the segment addition theorem? So we have RV plus VT is going to equal the entire segment of RT. And then we know that these two things equal each other. So if we have 22, then I know that RV is 11 and VT is 11. So VT is going to be 11. UV, we haven't addressed that yet. So we know that the entire segment of US is 18. So that makes this one 9, this one 9. And then we had just previously said that this is 11, this is 11. So we have UV is going to be 9. RS, we haven't figured out RS yet, but we have a way to. And ST. Now, these two segments right here are going to be the same, because RS and ST. But what we can do now is we can actually use the Pythagorean theorem. They have given us one side, another side, and we're missing the hypotenuse. We know that these are right triangles because they intersect at a perpendicular. So we can use the Pythagorean theorem to find ST and RS. So we have a squared plus b squared equals c squared. A squared can be 11. B squared can be 9 squared, and that's going to be equal to that hypotenuse. Let's see here, 121 plus 81 is equal to c squared. So we're going to have 202 is equal to c squared. And we find the square root of both sides. So c is going to be equal to, it's going to be equal to the square root of 202, or approximately 14.2. So 14.2, and then they are both the same length, so 14.2. So we're able to use those properties and characteristics of a rhombus to find some missing side lengths of a parallelogram. So as we continue talking about these special parallelograms, we're going to talk about a square. And a square is both a rectangle and a rhombus. So squares are both rectangles and rhombus. So if we look at this, we can see that we have 4 congruent sides, just like a square and a rhombus. We have diagonals which intersect at a 90-degree angle. And let's see here. So there's our 90, or I'm sorry, there's our 90 where the diagonals intersect. We have those 4 congruent sides. We also have four, just like a square or just like a rectangle, we have four 90-degree angles, or four right angles in that case. And then these diagonals are also angle bisectors, so we know then that this would be 45 degrees, and this would be 45 degrees, and of course 90 degrees. Let's see, and I think we may have covered briefly all the characteristics. So, of course, they are parallelograms. They have four congruent sides. They have diagonals that are perpendicular bisectors. They have four right angles. And they have blank diagonals. What did we cover with that? They have congruent diagonals, right? Because that's part of a rhombus is in a rectangle. They have congruent diagonals. And let's see here, if I do some modifications here, we know that we have the diagonals are going to be angle bisectors, sorry, and then we have perpendicular diagonals. So there we go. Solving problems with properties of rectangles and squares. So it says Sanjay has 250 feet of fencing to use to enclose a rectangular grassy area for his dog to play. Now he wants to use 80 feet of his house as the width of one side of the play area. What is the maximum length of the rectangle? Rectangle can have maximum length the rectangle can have. So here's my house. And I know that he wants to use 80 feet of his house. So I know that this is going to be 80 feet. So that means as a rectangle, the opposite side is going to be 80 feet because opposite sides are congruent. And they want to know what is the maximum length the rectangle can have. So here's my length. And let's see here. I'm going to have two lengths. So if I start off with 250 feet of fencing and I subtract 80 feet, this 80 feet right here, that's going to leave behind 180 feet of fencing. And I have the opportunity to use two lengths of that. So that would be 170 equals two lengths divided by 2. And I know that one length is going to be 85 feet. Okay, so this is going to be 85 feet. And there you go. I was able to make some determinations based on the properties of rectangles. Now here it says we have this new walking path around a playground. Around a playground is in the shape of a square. What is the approximate distance from one corner of the path to the corner opposite? So we are looking for opposite angles, right? So for example, this angle and this angle, those are opposite angles. What is the distance between angle C and angle A, or the vertex, those corners? So let's see here, what can we do to figure that one out? If we know that one side, it is a square, rhombus square, we have 90-degree perpendicular bisectors, we have 90-degree corners. I know that this side is congruent to all the other sides, and I need to figure out this length right here. So if I were to use the Pythagorean theorem, this is some unknown value. I can use that to come up with a squared plus b squared is going to be equal to c squared, in which case, this case, we have a, b, and c would be my sides. So I have x squared plus x squared is going to be equal to 80 squared. And combine like terms, I have 2x squared is equal to 6,400. Divide both sides by 2, and x squared is going to be equal to 3,200. Find the square root of both, right? Square root of both, because I want to find out what this value is. So x is going to be equal to approximately, right, we're going to round, approximately 56.57 meters, right, meters. So now if I have two of those, right, from here to here would be 2x, so I would have 2 times 56.57 meters is going to be equal to approximately, right, approximately 113 meters, because I rounded to the nearest meter, right, round to the nearest meter. So approximately 113 meters from opposite corners of my walking path around the playground. There we go. So as we continue to use these properties, so let's see here, as a special parallelogram. Gosh, that looks like a rhombus. Example number 5. The length of LN is 28. So this is 28. And this piece would be equal to this piece. So if that whole length is 28, this would be 14 and 14. And it says, what is the length of LP? Well, guess what? LN divided in 2 is equal to, sort of messed that one up, didn't I? L not 2, but LN divided by 2 is equal to LP. So 28 divided by 2 is LP, which is also 14. There you go. Mathematically and pictorially. Now, let's see. Looking at example number 5, it says if ABCD, this quadrilateral, is a rhombus. What must be the value of x? Well, we know that rhombi have a perpendicular, their diagonals are perpendicular. And they also bisect each other. But more importantly, I just know that they're perpendicular, and that's going to give me the information to know that that angle is equal to 90 degrees. So I know that angle BMC is equal to 90 degrees. I know that BMC is also equal to 5x plus 25. So I can use the transitive property now and make them equal to each other. So 5x plus 25 is equal to 90. Subtract 25 from both sides, and 5x is going to be equal to 65. Divide both sides by, not x, but by 5. And x is going to be equal to 13. So the value of x is 13. So I was able to use this relationship, knowing that they are perpendicular right angles, to find the value of x in a rhombus. Looks like example number 7 is also a rhombus. So as we see, FGHI is a rhombus. Find the measurement of HGI. Okay, rhombus, 90 degrees. This is congruent to this. Parallelogram, though. Parallelogram, remember that these two things, this angle plus this angle is going to be equal to 180 degrees. Or I know that this angle plus this angle should equal 90. So let's see here. I am going to say that 7x minus 1 plus 4x plus 3 is going to be equal to 90 degrees. Because the internal angles of a triangle, right, are equal to 180 minus 90 would give me 90 degrees. So go ahead and combine like terms, and I end up with 11x plus 2, because 3 minus 1 is 2, is going to be equal to 90. Add 2 to both, not add 2, inverse operations, right? Subtract 2 from both sides. 11x is going to be equal to 88. Divide by the coefficient of 11, and x is going to be equal to 8. So we found out that x is equal to 8, but that's not what they wanted us to know. They wanted us to find out HGI. So HGI, they want us to find out the measurement of HGI, which is this angle right here, and we know that this angle is, those alternate interior angles are going to be congruent. So we can also use corresponding parts of congruent triangles to find that out, but we know that that angle, angle HGI is equal to 4x plus 3, which is equal to 4 times 8 plus 3 is 35 degrees. So there you go. HGI is equal to 35 degrees. There you go. Let's see, continuing on with example number 8, we have a rectangle now, and ABCD is a rectangle. It says find x and the measurement of CAB. So they want us to find this measurement right here, and also they want us to use x. And as we just stated in that previous problem, these parallelograms, the alternate interior angles, right, are going to be congruent. So I can use that congruency to find the value of x, because I know that 7x plus 5 is going to be equal to 11x minus 3, and you can combine like terms using your inverse operations. And I have 5 is equal to 4x minus 3. Add 3 to both sides, continuing to isolate my variable. And I have 4x is equal to 8. Divide both sides by the coefficient of 4. And x is going to be equal to 2. So if x is equal to 2, in order to find out this, that's one thing I just found out. X is equal to 2, but the measurement of angle CAB, well, angle CAB is equal to 7x plus 5, which is going to be equal to 7 times 2 plus 5 is going to be equal to 14 plus 5 is 19 degrees. So there you go. CAB is equal to 19 degrees. And I was able to use the properties of these special parallelograms to find missing values and determine what angle measurements were, what the values of x were. So using the properties and the characteristics of these special parallelograms will benefit you in solving problems in a simpler way. So we'll go ahead and continue with our classwork and see how it goes.